Hello everyone. Today we shall be going through the origin of the quadratic formula. This formula on the screen is, I'm sure, a very familiar formula for most of us, and it can be used to solve the two solutions, to find the two solutions of x of any quadratic equation. All you're going to need are the coefficients of x squared, denoted as a here, and the coefficient of x, denoted as b here, and the value of c. You just plug these values into the formula and you're just going to get the value of x. You have solved for x. To actually understand how we derive this formula, we are going to need a small prerequisite, which we shall be going through before actually deriving it. And that's this technique called completion of the square. Let's get into it. Consider this term, x plus 1. We take the square of that. If we expand this, what we are going to get is x squared plus 2x plus 1. What you can notice here is that this is just the square root of x squared, and what you have over here is just twice this value. So the coefficient of x, when you expand, is just twice the value of what you have over here. And what you get over here is square of what you have over here. So this is 1 squared, and this is 1 into 2. And over here you just square this term. So this pattern is something we can see. Let us consider another example. X plus 3 squared. So that is equal to, when you expand it, you get x squared plus 6x plus 9. So let us see that trend again. So just as I showed you before, this has got squared. So x was just squared to get x squared. And here, this value, 3, we get twice of that as the coefficient of x when you expand this. So you get 3 into 2, and that's 6. And then if you consider this term, that's simply the square of this 3. Since 3 squared is equal to 9. So this is a familiar pattern that you can see when you square any of these particular equations. So anything, x plus anything, x minus anything, you get the similar pattern. So if we consider a general case, x plus a whole thing squared, you're going to get x squared plus 2ax plus a squared. So this pattern that you see over here is a very important thing that we need to see before we get into this completion of the square. So now let us get into it now that we've seen this pattern. Consider a random quadratic equation, or let's say just a quadratic expression just for now. Something like x squared plus 4x, something random, plus 9. So if we want to get this in the formula, in the format, something like x plus a squared, maybe we can go this way and reverse this pattern and come here. So what you can do is, if you reverse this, what you're going to get is, if you go backwards, what you're going to get is, now x, when you went forward, x became x squared. So you go backwards, it becomes x. And then a becomes 2a here. So over here, we just get the half of this, which is 2. So 2. and then square. But the problem is when you square this, what you get is x squared, just as we have here, plus 4x, still alright, but then you get the square of this over here, 4. But that's not what we have over here. What we have over here is 4. What we want is 9. So simply doing this is not going to work. We are going to need to complete that square to get this 9 over here. So what we can do for that is, our goal is to get 9 over here. So what we do simply is x squared plus 4x plus 4, we subtract 4, add 9. 4 gets cancelled by subtracting 4 out of it, and we are left with this 9. So if we do that now, since this particular part is equal to this, we just take this over here and x plus 2 square. So that was what this entire part was all about. And then we just do what we did over here. Minus 4 plus 9. That is equal to x plus 2 squared plus 5. So this process is what we call completion of the square. To make sure that we have a concrete understanding of this, let us take another example. Let's consider x squared plus 6x minus 20. So we follow a similar procedure as earlier. We get the square root of this, that's x, and then plus half of this, that's 3 squared. So if we expand this, we are going to get x squared plus 6x plus 9. So that 9 we had to subtract. So that's basically the square of this. So minus 9. And then just add in what we were missing. Minus 20. And that we can write as x plus 3 whole thing squared minus 29. So I hope you understand what this completion of the square technique is. Now that we know what completion of the square is, let us go into the derivation of the quadratic formula and understand its origin. To understand how we derive the quadratic formula, we need to understand the quadratic equation. So let's rewrite it. Ax squared plus bx plus c equals 0. Then we simply conduct completion of the square on this and bring it to that formula, that the format that we discussed earlier. And also another important thing is that when we conduct completion of the square, we must always ensure that the coefficient of x squared is 1. So to do that, we are going to factor out a first. When we factor out a, we get a out, and then x squared plus b over a x, and then plus c. That's equal to 0. And then we can conduct completion of the square on this particular component. So when we do that, we get a x plus b over 2a squared minus the square of this part, so that's b squared over 4a squared, close the bracket, plus c, and that's equal to 0. Then we expand a x plus b over 2a squared minus b squared over 4a plus c equals 0. After that, it's just a matter of subjecting x and basically solving for x. So to do that, we take both of these two terms to the opposite side of the equal sign. That's a x plus b over 2a whole thing squared equals b squared over 4a minus c, and that can be written as b squared minus 4ac over 4a. And then it's a matter of dividing both sides by a. That gives us x plus b over 2a whole thing squared equals b squared minus 4ac over 4a squared. And then we take the square root of both sides. That gives us x plus b over 2a equals plus or minus the square root of b squared minus 4ac, and we know the square root of 4a squared is equal to 2a, so we divide by 2a, and then we just take this term to the opposite side of the equal sign to give us x equals minus b plus or minus b squared minus 4ac square root of that divide by 2a. And you can see that this formula is exactly what we have over here. I know it has been a long way from the completion of the square method all the way to this formula that we had derived here, but I believe that this derivation will give you greater insights and actually let you understand how you came to your answer when using this formula. If you have any questions, please feel free to post your questions in the comment section. That's it for today. Thank you.